Hi, welcome to our ACT science lesson. We're going to be talking about the data interpretation passages today, which are one of the most common passages on the ACT science test. I'm Sophie Heller. Some know me as the lady in the videos. You can call me Sophie or the lady in the videos. So as I said before, we're going to be talking about the data interpretation questions. And there are three types of passages on the ACT science section: data interpretation, research summaries, and conflicting viewpoints. But we'll just look at the data interpretation. And more specifically, it's something that's similar to what you may have seen in science journals or even your textbook. And it's a format that combines some graphic material, some tables, in conjunction with some written words. So we'll see more how this works when we look at some real passages. So the data interpretation passages make up 30 to 40% of the science test. So mastering this type of passage is really fundamental in getting a great science score. They're the second most difficult passage type to improve, so right in the middle. But there are a couple ways that you can improve. So you can take notes as you read just to keep straight. There's lots of data. It's hard to pay attention. They're usually pretty dry, so notes will really help. You can understand the types of questions, and that's what we'll do today. We'll look at a few different question types. You can understand the purpose of each paragraph, which is something that you should generally do on any reading-based test. So the ACT reading test, the ACT English test, and of course the science test. And one thing that you can do to really improve your score is to look for patterns in the data before looking at the question. So it's called the data interpretation. You're going to have to interpret data, so you might as well make some strides in recognizing these patterns before jumping right into the questions. So there are five types of questions that we'll look at today. We have necessary inference questions, figure interpretation questions, so exactly what that sounds like, pattern recognition, so we're going to be looking at patterns and just trying to see which values change other values, hide and seek questions, which are the same as you'll see on the reading section. So you're just trying to find information in a specific part of the passage, and definition passage, so pretty self-explanatory. So let's look at an actual passage to get a better idea of what's going on the data interpretation section. I want you to pause and read this passage. You can also use the link at the bottom right corner to see it on the tested website. But regardless of how you read it, let's just pause here and let's regroup when you've familiarized yourself with the passage. Okay, I'm assuming that you've paused and read the passage, and if you haven't, you can still pause the video at any point to go back and read the passage. So let's begin. First, we want to talk about finding patterns. So here's some examples of the patterns we're going to see in this passage. On the left-hand side, we have the vertical temperature profiles. And the vertical temperature profiles show us four diagrams, and we're looking at how precipitation falls. So we see that in figure A, we're only looking at some really cold temperatures, so -10 degrees Celsius. Precipitation is going to fall as snow along this curve. In chart B, we see that precipitation falls first as snow, then it becomes sleet when you pass the freezing line, and then right back to snow. In chart C, we see that it falls as freezing rain. It'll start as snow, and it'll make a bit of an arc curve, but above the freezing line. And the most rare combination is actually rain. So we'll see it'll start as snow, and then it'll cross the freezing line and continue on as rain as we get into the warmer temperatures. There are also two tables in this passage. So table 1 talks about our surface temperature range, so the different temperature ranges on the surface, and the type of ice that's formed. So we see that when we are in a warmer range, we see that there's less ice, so they're thin plates versus plates, which are assumed to be thicker than thin plates. In table 2, we see a comparison of the height in the atmosphere and the observed temperature. So we see as we go higher, the temperature's lower. And that's something that you probably remember from if you've ever been on a mountain or been skiing. Okay, so let's dive into our different question types. So the first question type is the necessary inference. And the necessary inference is kind of like making your own assumption based on the passage. So some examples of this are: the best method of identifying minerals is, or why would propping the counterweight improve the efficiency of the trebuchet? And I don't know a lot of those words, so we're going to have to look at that passage later. Or suppose that energy fluxes were recorded on high-resolution X-ray film. How would this new information affect the two theories? And remember, these are only based on the passages, so you don't need to know about minerals or X-rays or whatever's happening in question 2. You just want to see what's going on in the passage, and a necessary inference is something that must be made given the data. It'll be very straightforward. So our strategies are, you don't want to reread. So if you're rereading the passage, you weren't reading closely enough to begin with, and you're wasting a lot of time. You want to be efficient. You want to pay attention to the first paragraph. The first paragraph is usually going to define some key terms and set up the experiments. So you're going to see a lot of setup in the first paragraph, and then you'll either just have charts and tables, or you'll have a couple more paragraphs. You also want to make sure that you're looking more closely at data than assumptions. So a lot of trap answers will often include something that is discussed in the passage, but it contradicts what the results actually prove, or it explains something differently. So make sure not to go for something just because, oh, I saw this term in the passage, it must be right. Never a good strategy. Let's look at an example of a necessary inference question based on this passage. So the question reads, based on the passage, what conclusion can be made about how precipitation forms in the atmosphere? And we know that it's a necessary inference question, so we're going to want to look at this first paragraph before the charts. And it tells us that prediction of snow is very difficult. We know that snow changes to sleet, rain, or freezing rain, and snowfall amounts are equally difficult to determine. So we see a lot about snow. And if we look at these vertical temperature profiles, I know that they're not in the first paragraph, but just to get a bigger idea, we see that everything starts as snow. So on the left-hand side of the chart before that dashed freezing line, before becoming sleet or freezing rain or just normal rain. So we want something about snow. So if we look at choice number 1, we see precipitation usually forms as snow. I'm going to say that's probably right given our charts and given all the talk of snow in the first paragraph. But let's look at our other choices just to see if that makes sense. Choice 2 tells us precipitation always begins as rain. That's blatantly false given those charts. So we know that that can't be true, so let's just get rid of that. Choice 3 tells us freezing rain forms at a height of 3,000 meters in the atmosphere. We don't know that. So we know that we see 3,000 meters in table 2, and we know that it correlates to an observed temperature of -8 degrees Celsius, but we don't know if that means freezing rain. We can't make that assumption. And choice 4 tells us snow may change to rain, but then usually reforms into snow. That's directly contradicted by this figure D. We see that the snow is crossing the freezing line and just becoming rain. So it could go back to snow, but we can't assume based on the passage. So the only thing that we can safely say is choice A. Let's look at figure interpretation questions. These are going to be much more straightforward. Figure interpretation questions ask stuff like, refer to the data in table 3. As the water temperature decreases, the life expectancy of the snails, ... So actually looking at a certain table. Or if resistor R1 was a 15 squiggly line resistor, the voltage would be. Or according to the experimental data, if the distance along the slope is constant, the tension along the rope is proportional to. So you'll see that they'll either directly allude to a certain table, like in our first example, or they'll ask us some data that requires us to look at a chart and just form a mathematical decision. It seems a little intimidating, but these are much easier than the necessary inference questions. Here's some strategies. You want to look for those patterns you observed. So think of this as a matching exercise. If you've looked for patterns and identified them before looking at the question, you should be able to find something similar in the answer choices. So it's much easier to form your own opinions and look for something that matches up with that, rather than kind of looking for a needle in the haystack and trying to determine an answer before you familiarize yourself with the data. You can double check the figures. So before settling on an answer choice, you want to look over all the tables and graphical material that have to do with those variables that are chosen in the answer choice. You also want to focus only on the numbers. A lot of trap answers are going to refer back to the hypotheses in the setup or that first paragraph, but the data might disprove the hypothesis. So it doesn't always go together. So these types of questions, just look at the chart they're directing you to. Here's an example from this passage. It tells us that the surface temperature at the observation time was 30 degrees Fahrenheit and 1 inch of liquid equivalent snow was measured. How much snow would be expected to be on the ground at the time of observation? Okay, so we want to look for something, so we know it's 30 degrees. So let's look at our table that talks about different temperatures in Fahrenheit. So we know we're going to look at this. Chart. So sadly, looking at this chart now, we have 32 to 25 and 25 to 14. So I am reading this wrong, and we're going to look at 32 to 25. Okay, so now that we've assured that, we know that between 32 to 25 degrees, which encompasses 30 degrees Fahrenheit, we're going to see a ratio of 8 to 1. So this is telling us ratio of 8 inches of snow on the ground to 1 inch of liquid equivalent. And so if we're asked how much snow is supposed to be on the ground, we have an 8 to 1 ratio, 8 inches. It's really that simple. Just make sure you read the charts right, which is something that causes me difficulty sometimes. Okay, let's move on to pattern recognition questions. So very similar to what you did in the beginning of the passage by initially just trying to determine that data. So pattern recognition questions look a little bit like, what type of damage would be expected if a hurricane was reported to have a barometric pressure of 933 MB and a storm surge of 5.0 meters? So you're trying to make an extrapolation, but based on patterns that you've already recognized. Or if a researcher burned 15.0 milligrams of the white powder in the combustion apparatus, how many total millimoles of oxygen would be formed? Or what will the approximate ratio of 39Y91 be after 2.7 days if the initial samples of the two isotopes contain equal numbers of nuclei? So these are just going to be based on patterns. You won't have to come out of these numbers with bring these numbers out of thin air. Some strategies. As I said before, you want to extrapolate from the patterns you observed. So think back to those patterns you found in the data and try applying them to these new situations. Make use of all the givens. So you want to look for data that your models may not have accounted for. And this is a sign that you may need to rethink a pattern or look for something you missed. Also, don't overthink it. So it should only be based off of inferred patterns. So don't go off anything that, even if you've learned something in chem or bio, we don't know. We have to assume that we know nothing, and we're doing these questions just with the material in the passage. So you will find the answer based on the stuff in the passage. Just don't think about real science when you're doing it conversely. Here's an example from this passage. So we see that two locations, A and B, receive the same amount of snow on the ground and the same amount of liquid equivalent. What conclusion can be made if these two things are the same? So we see the same amount of snow, same amount of liquid equivalent. So they're probably going to be pretty similar in this regard, our vertical temperature profile. So if they're seen, because if they have the same amount of snow, then you'd assume that it's going to be constant snow and they're not going to have rain or sleet or all these other things that happen when we cross the freezing line. We're also going to assume that their temperatures are probably pretty similar because when our temperatures are similar, we have similar ratios of snow to liquid equivalent. So if we look at our choices, we see both locations had similar vertical temperature profiles. Yeah, that's probably true. Both locations had approximately the same surface temperature. Also true given the ratio of snow to liquid equivalent. And choice C, the type of snow crystals that fell were different at the locations. So that actually goes against what we've seen because the type of crystals depends on the temperature. So if they have about the same temperature, which we know because they have the same amount of liquid equivalent and the same amount of snow on the ground, then we know that choice C can't be good. And so since A and B are both valid, let's go with choice D, which says that both A and B are correct. Great, let's move on to a different type of question, the hide and seek question. So these are just finding information in the passage. So the hardest thing is not answering the question, but just finding where you need to look. So hide and seek questions ask things like, Scientist 1 mentions genetic homology between humans and birds to show that. So you're going to want to look for where we see genetic homology in the passage and answer the question based on that. Or according to the passage, sample B should be classified as a lanthanoid because, so we probably want to look for lanthanoid and go from there. Or finally, although they reach different conclusions, both environmentalists appeal to our concern for, so we want to see what's happening that both environmentalists say. So some strategies for hide and seek are, well, they're really common when multiple experiments are being discussed, which we unfortunately see sometimes. You want to hunt for a specific keyword. So before where we saw lanthanoid or we saw conclusions from both scientists, we want to just find those words because it's going to be much easier to skim the passage with a certain word in mind. And you can also use your hand to scan faster, and it makes your reading comprehension better even outside the ACT. So, use whatever strategy you find best, but no harm in using your hand to read the thing faster. Here's an example from this passage. So it's telling us, according to the passage, what's the greatest complication for a meteorologist in forecasting snowfall? So we're probably going to be looking in the actual written part of the passage because the data doesn't tell us anything about meteorologists. So I'm going to say meteorologist is a good word. It's a big word. It stands out. Let's find that word. So great. So we see meteorologist in the first sentence of the passage. So the prediction of snow is very difficult. And why is it difficult? So we see snow changes to sleet, rain, or freezing rain. And it accounts for a lot of false predictions. The amounts are equally difficult to determine. So we see probably what's going to be difficult is that the snow, it's not always snow. So the snow is going to change once it passes the freezing line. It's going to change into different expressions of precipitation. So that's probably going to be the most difficult. So let's see in our choices what goes best with what we just saw. Choice A tells us identifying the altitude at which precipitation crosses the freezing line. But this isn't based on altitude, this is based on temperature. So that's not good. Choice B, the threat of snow changing to sleet, rain, or freezing rain. That could be true. Choice C, predicting the amount of precipitation and foreseeing changes in its state of matter. I'd say that sounds better. So it's not really the threat that it's going to change to something else, but it's just knowing what do we count as snow and what do we count as something else because the snow is on the verge of changing to another state of matter. So I'd say that's probably a better choice than B. And choice D tells us forecasting the vertical temperature profile. That's not going to really help us. That's just based on temperature. So I think that choice C is going to be a better choice than choice B. It's more general. And finally, we have our definition questions. And those go a little something like, compared to water-soluble substances, such as glycerol and ethylene glycol, penetration of ethers, ketones, and aldehydes across lipid membranes is. So really long question, confusingly worded, but not that bad if you find that in the passage. Or which of the following best describes the immunological role of B cells? Or finally, luminosity refers to the type of brightness that can be determined across which of the following ranges. And again, these are things you'll see in the passage, so no need to bring out your science vocabulary from other sources. Some strategies. You don't want to run from the word, run to the word. So this is very inspirational. Don't be afraid. You don't need to know any fancy scientific terms. They're all in the passage. So you want to scan for the term the same way that we did with our hide and seek example just before. You want to pay attention to the first paragraph. As we said in the hide and seek passages, different types of questions, the first paragraph often contains these key terms. And you want to watch out for the data trick. So sometimes definitions may change depending on the function of the object being defined. And these trap answers will play on how the data changes your understanding of the definition. So basically, don't get confused about what's happening with the data. Just look in the passage for how the author defines the key term. Here's an example from this passage. So what type of precipitation is most likely to fall? There's a very shallow layer of very cold air below freezing at the surface only. So we want to see where that is in our passage. So you see very shallow layer of very cold air. And if we see that, I'm going to look in our first paragraph, just like with hide and seek. Rain freezing on contact with the surface due to a very shallow layer of cold air in the atmosphere. So that's going to be exactly like what we just saw. And that's telling us freezing rain, defined by what's in these parentheses. And sure enough, freezing rain is one of our choices, so that's what we're going to go with. So very simple. We don't have to care about what's happening in the rest of the passage. No actual looking at data. So these are all the types of questions you'll see in the data section. And I hope that really helps you out. And be sure not to be afraid of these or intimidated because it's science, because all the answers are right there in the passage. So good luck with the ACT science section, and hope this helps with the rest of the test.